सबसे पहले आता है विजिबिलिटी. व्हाट डू यू अंडरस्टैंड? व्हाट इज विजिबिलिटी? व्हेन वी टॉक अबाउट विजिबिलिटी तो क्या आता है आपके मन में?
The maximum distance which we can see
objects
at sea.
Isn't it? Yes. So basically, technically, transparency of the medium. Isn't it?
Transparency of the atmosphere.
Yeah, transparency of the medium, that how far at sea we can see the ships, we can see the objects, we can see anything. And यही visibility जो है, it gets good, it gets deteriorated if something is there in the atmosphere and if the atmosphere is clear. So this is what basically your visibility. Visibility is the transparency of atmosphere and defined as the maximum distance at which an object can clearly be seen in normal daylight. So how this visibility changes? Now, bad visibility we call maybe due to the presence in the air of visible moisture in the form of liquid, water droplets, not water vapor, which is invisible, or solid particles such as dust, smoke, or sea salt. Very common. Nowadays you will be seeing कि अंधेरी चल रही है, dust storm आ गया. At sea also sometime passing Red Sea, you see this sand flying, and due to the sandstorm, and you see your visibility getting affected. But basically if you see, so these are the various things where the transparency of the medium can be affected. Now good visibility, again if we see, is favored by air temperatures which are below that of underlying surface and by strong winds. So ये जो सारी visibility का जो main reason है, what we call is the fog. और इसकी भी terminology थोड़ी सी अलग है. Now when the horizontal visibility lies between 1000 to 2000 meters, the terms mist, haze are used. And the former only when the atmospheric obscurity is due to the presence of moisture, and the later when due to solid particles. Now the term fog is applied when the visibility, irrespective of the cause, is below 1000 meters, half a nautical mile. So we always say yes, we are going into the restricted visibility. And then you say poor visibility means zero, cannot see. So there is a difference again in your restricted visibility and poor visibility. And you may have experienced sometime a very thick fog where you can't see even the forward railings just in front forward of the bridge. Forget about seeing the mast. Isn't it? So forward mast तो दिखता ही नहीं है, even कई बार forward के आगे railing है जो आपके लगे हुए, वो भी नहीं दिखते. Now visibility which is impaired but is more than 1000 meters is described as mist, and when caused by water droplets, and when the relative humidity more than 95%, when caused by smoke or dust particle, it is described as haze. Very common term we write hazy, horizon is very hazy, isn't it? So ये जो haziness और ये जो mist है, this is basically, if you call, the causes of this range from forest fires, smoke from industrial areas, or dust or sandstorm which may be experienced to seaward of desert regions such as of West African coast or of Arabian coast when seasonal winds blow off the land. तो ये तो है कि yes, आपकी जो haziness है, it is due to these factors which are causing. So sandstorms may extend up to 100 miles out to sea, constitute a serious problem for the mariner. I don't know how many of you have experienced very common Red Sea. एक तो विजिबिलिटी खराब, ऊपर से सारा शिप जो है उस पे मट्टी मट्टी जैसी आ जाती, ब्रिज फ्रंट जितने वाइट स्ट्रक्चर है सारा लाल हो जाता है टू वॉश. हमारे लिए तो अगेन एक्स्ट्रा वर्क कम्स. सो नाउ कम्स द फॉर्मेशन ऑफ फॉग. बेसिकली फॉग हमने देखा है कि यस, इट इज इफेक्टिंग माय विजिबिलिटी. सो हाउ दिस फॉग्स आर फॉर्म्ड, वेरियस मेथड्स ऑफ फॉर्मेशन ऑफ फॉग्स. Sometimes the fog, certain fogs, they form only at sea. Certain form of fogs, it forms only on land. So we are more concerned about sea, that how the visibility gets affected, and I should be able to know. Now अगर आपको थोड़ा सा ये पता है, तो you can even predict, yeah, what is the sea water temperature, what is the air temperature. So now you know how the formation of fog takes place. So you can be very well prepared. And there are certain areas over this planet where you have permanent fog, or where the conditions are such that you will experience a thick fog. So वो भी हम देखते हैं. Now first of all, the formation of fog, if you see, the fog is formed by cooling of a large volume of air below its dew point. Now again, back to same basics, that when the air is cooled, so as the air rises, so air cooling can be done many ways. If it is climbing up the mountain, as the air rises, so basic thing, when the air starts rising, it expands and it starts losing its temperature, it starts becoming cold. And जैसे उसका temperature नीचे आएगा, the humidity starts increasing. So again you have seen the relative humidity is inversely proportional to temperature. And air saturate होनी शुरू हो जाएगी. So the moment air is 100% saturated, and then if it is cooled below that, इसके अंदर जितना water vapor है, it condenses into water droplets. So resulting in condensation, a process similar to that of cloud formation, but taking place at or near the sea or ground surface. Now in certain circumstances, it may also be caused by the evaporation of water vapor into the air. So formation of fog जो है, in a very simple terms, the necessary cooling referred to above, the cooling of the air is basically by proximity to cold land or sea, isn't it? That's how the air can get cooled, and some turbulent mixing of the air. So इन्हीं सारी चीज़ों को देखते हुए we have the types of fog. So what are the various types? We have advection or sea fog, what we call frontal fog, radiation, Arctic sea smoke, or orographic sea fog, what you call, isn't it? So this is basically the few forms of fog. So first we see advection fog, which is most commonly what we call the sea fog. This is the most widespread type likely to be encountered at sea, and is caused by, how it is caused, by relatively warm air being cooled by flowing over a cooler sea surface. Now if your sea surface is cool and the air is warm, so naturally you will find this fog formation. How? The latter will be below the dew point of the air, isn't it? After sea surface it is cooler, so now it is below the dew point of the air which is blowing up, which is pretty warmer air. So that's why if the dew point is below, and normally the wind speed will be between 4 to 16 knots, about force 2 to 4, and you find this fog taking place. Now there are only certain localities where such conditions are relatively prevalent. So ये कौन सी है? One of this is off the Grand Banks of Newfoundland. अब वहाँ पे क्यों ऐसा होता है कि वहाँ पे जो cold Labrador current, which is a very cold current coming from north, causes a decrease in sea temperature. Sea surface आपका cold current आ रहा है तो sea surface को ठंडा कर देगा. The warm moist southerly air stream flowing over this is cooled below its dew point to form advection or sea fog. Now this is a very common thing when you go off the Grand Banks of Newfoundland. So we are always day one say, यार we are going to pass this, first of all thick fog. आज तो चलो आपके पास you got little better radars, GPS, everything is there. And previously हमारे radars भी जो थे, they were not so good. 3 miles, 6 miles के बाद object आएगा नहीं आएगा, nobody knows, isn't it? Plus position. So today with the advent of this technology, GPS, you know every second where your ship is, how far you are from the coast, how far you are from any island. So that is not the problem. So only traffic. So you have to only see the traffic. उसके लिए आपके पास आजकल sophisticated radars है, आर पार है. So you can all see that. So fog में सबसे पहली चीज़ ये आती है कि yes, these areas, that's why these areas are considered dangerous, because there's a possibility of ships not being traced. So current causes a decrease in sea temperature. So ये जो cold Labrador current है, this will definitely decrease the seawater temperature, and the warm moisture blowing over this cold sea surface will definitely get cooled below its dew point, and condensation will take place, and finally you find the thick fog taking place. So southerly air stream flowing this, it causes, and this type of fog is what we call the advection or the sea fog, because it is forming mostly over the sea. Another place where it is forming is your English Channel, often affected by advection fog. When southwesterly winds reach the British Isles from Azores in the spring and early summer. So English Channel also are the again deadly places. So अभी भी है कि yes, when you are a watch keeping officer, you always become alert and you know these areas. आजकल of course weather report भी है. Yes, now I have a rough knowledge that English channel, अगर हम spring early summer में जाएंगे, there is a possibility of fog, so you are pre-prepared. That extra lookout या आपको lookout रखनी है या keep a watch because today the traffic is also increased. ये तो है नहीं कि पहले टाइम की तरह few ships were there. Now everywhere there's a lot of ships there. So इसके लिए इन areas की knowledge of Grand Banks of Newfoundland, English Channel, of Japan. Now Japan में भी क्या होता है? Off the east coast of Japan, where warm moist westerlies blowing over warm Kuroshio cross over to Oyoshu, which is a cold water. So there again you see this advection fog forming there. Why? Because of this warm Kuroshio. तो ये तीन जगह है जहाँ पे advection fog आपको very commonly आपको मिल जाएगा. So it is possible to estimate the likelihood of the formation of fog from observations of air temperature. ये भी हम कर सकते हैं. आप log book में भरते हो sea water temperature, air temperature, wind direction, other weather signs, plus a knowledge of sea temperature to be expected on the course ahead. So you can definitely even predict when this advection fog I will encounter. So ocean routing charts अगर आप देखिए, most of you must have seen. So वो भी important है, ocean routing charts, उसके ऊपर क्या क्या information है. So there also if you see this thick fog areas are predicted there. So they are mentioned. And उनके अंदर आपको what you call this routing charts पे mean sea water temperature is given, dew point temperatures are given, percentage frequency of fog, visibility less than half a mile, those areas are also marked. So इसी कितनी information है. Only thing is I should know which information to get from where. Even अगर मैं उसको भी खोलता हूँ during the passage planning or when we are moving. So पहले paper chart होते थे. So second officer जो passage planning बनाता था used to mark there कि thick fog is expected, because used to go through these books, these charts, and then highlight for the duty officer, for anybody कि these areas fog will be present. So please be careful. So idea is I should not be taken by surprise. Suddenly हम चल रहे हैं and you find there is a thick fog. Percentage frequency of low visibility, that is also given in your routine charts. Mean air temperatures, barometric pressures. तो इन सब से अगर आप देखिए तो you can even predict, अगर आप इसको plot करते हैं local time पे, the dew point temperature and the sea temperature को अगर आप करते हो, wherever these two temperatures are meeting, so you can predict that this is the place 1400 hours that there is a chances of sea fog forming. जैसे ही sea water temperature आया और ये dew point का curve जहाँ पे मिलेंगे वहाँ पे fog will be there. तो ये तो रहा आपका advection fog. How this fog is forming, mostly you encounter at sea is the advection fog, and the areas you have seen where this fog is very much prevalent. So radiation fog, now this forms over land mostly frequently during autumn and winter over low-lying land, especially if it is damp and marshy and in valleys on quiet nights. क्यों? With clear skies. Why this radiation fog and how it forms? Under these conditions the land loses heat by radiation. इसीलिए से radiation fog कहते हैं कि night time जब आपकी, we have studied that there is no incoming radiation from the sun, so the land starts losing heat, it starts becoming cold. So naturally the air है that also in contact with this land also starts becoming cool because of the radiation of the heat. So possibly too, and जैसे ये air ठंडी होगी, so it's possible that if it gets cooler, then the dew point condensation will take place. And if there is a gentle breeze blowing up to say 5 knots, this will cause turbulent mixing. Okay, mixing होगी, so only close to the surface and condensation in the form of fog will take place. So radiation fog is only possible on the land. Why? Because of the land during the evening, night time, losing heat and becoming cold. So the air also in contact with the land also becomes cold, and if it becomes cold below its dew point, condensation. Stronger wind will cause the cooling to be diffused through a greater depth of air and the dew point will not be reached. So इसके लिए gentle breeze चाहिए, stronger breeze होगी तब भी fog formation जो है not possible. Since cold air is heavier than warm air, it will tend to drain down into the valleys. So naturally अगर आप देखिए down in the valleys आपका total complete एक blanket of fog will be seen to you. Although it is never actually forms over the sea, it may drift from land for several miles, but seldom extends for more than 10 miles offshore. So अगर आपकी sea coast है, it is close to the high mountains, so there is a possibility that this can drift down, but again it is restricted only on the coastal areas. But coastal में भी of course हमें navigation तो करनी है, ships have to go to the port. तो यहाँ पे भी problem रहती है कि yes, when approaching a port, if you have a fog और भी dangerous हो जाता है. So radiation fog will most dense around sunrise and normally disperses fairly rapidly as the land warms up. So the radiation fog, I think very common that you have seen how the land gets heated and how the land gets cooled due to the solar energy. So night time there is no solar incoming radiation is there. So that's why you see this land becomes cooler and the radiation fog forms. And this is what basically night time is taking place. Land cooling at night time and this cold air again rising and then getting cooled below the dew point and converting all this water vapor into the water droplets. Now, conditions favorable for radiation fog. क्या क्या हमें होना चाहिए? Large moisture content in the lower layers of air, little or no cloud at night, clear skies, then only this radiation of heat from the land will take place. अगर cloud cover होगा तो फिर तो land ठंडी भी नहीं होगी. Light breeze at the surface and cold wet surface of land. So when all these conditions are met, all these conditions are there, so you see this land fog or the radiation fog forming. तो ये तो आपका हो गया radiation. अब सी में और क्या होता है? Arctic sea smoke. Now Arctic sea smoke क्या है? This is a type of fog occurring close to the sea surface. Now when the air is dry and cold, probably at least 9 degrees centigrade below the sea surface temperature. अब ये क्या है? Now the air is very cold and rapid evaporation takes place from the relatively warm sea surface. So पहले तो था कि cold sea surface and relatively warm air was blowing over this and we were seeing this advection fog forming. अब यहाँ पे उल्टा हो रहा है कि आपकी जो सी सरफेस है that is relatively warm as compared to the wind or the air which is blowing over it. So relatively warm sea surface into the colder air and condensation takes place giving effect of steam or smoke rising from the sea. अब आपका जो sea है that is relatively warm and the air above it is pretty cool. So it is 8 to 9 degrees below the sea surface temperature. This Arctic, that's why it's called Arctic sea smoke, because it takes place on the very higher latitude near the Arctic areas, because the wind is very very cold there and it looks like basically like a streams smoke, like a smoke you can see. That's why I call it Arctic sea smoke. It literally appears that the sea is smoking like this. There's the smoke rising from the sea. It is because of that warm sea surface, this air which is just in touch with this warm sea surface, it is getting cooled because of the adjacent very cold air in touch with the sea surface. Now it's most common in Arctic and Antarctic waters and in the Baltic, but it can also occur off eastern coasts of continents in winter. For example, off Newfoundland or inland seas and lakes. And this is one of the fog which may also be associated with strong winds, because since it requires a continual supply of cold air. So Arctic sea smoke, if you go to higher latitudes, so you may come across, because it is a very cold breeze, very common, that is blowing over a relatively warm sea surface. So we have fog formation देखिए, yes, it is basically controlled, or formation takes place between the difference in temperature over where the air is blowing. So if the air is blowing over sea surface, if the sea surface is warm and the air is cold, then you have this Arctic sea smoke, and if the sea surface is again cold and the warm air is blowing, then you have the advection fog. And radiation you have seen because of the land. Now the land is getting cooled and then you find that fog taking place. So these are the basic, very basic few reasons that you see that fogs forming, and we can definitely see. Now another is a orographic fog or hill fog, what we call. Now हमने cloud formation भी देखी थी, orographic method of cloud formation. Same thing is here. When a wind comes against a mountain range and begins to climb over it, so it progressively cools adiabatically. So that we have seen without any heat getting transferred. So that's the adiabatic process. And this air which is rising or going up the mountain, it progressively gets cooled, and after the dew point is reached, any further cooling causes the excess moisture to condense into water droplets, forming a hill fog or orographic fog. So basically oro means mountain, so you can simply that hill fog formation is also possible. Hilly areas very common now in this rainy season. If you go towards the hilly areas, so you will find that totally complete blanket of this fog will be seen, because as the air starts rising from the low lying areas, जैसे ये ऊपर जाती है, it gets cooled, and cooling below the dew point, this system takes place. So थोड़ी सी precautions हैं आपकी sound signals in the fog, कि आपने fog देख लिया, fog formation you have understood. Now the possibility कि यार इसका effect क्या होगा. One we have seen that yes, visibility, my visibility is affected, I cannot see, so we have to be very careful. We use the radars, we keep extra lookouts and all that. And also you see when you also give the sound signal. Now sound signals in fog, the very conditions which create fog may also cause distortions in both direction from which another ship's fog signal appears to come and in its strength. इसके लिए अगर आपका fog है तो of course we see the fogs, and very common you see कि due to this thick fog it is very difficult to make out कि अरे आप ship का fog signal कौन सी direction से आ रहा है. So it is very misleading. So this is also one of the effects because of the conditions of the atmosphere जिसके अंदर आपने sound ने travel करना है. So sound also gets affected because of these different conditions in the atmosphere. Watchkeeper therefore exercise considerable caution when attempting to estimate either distance from another sound source or its direction. So ये भी आपके लिए precaution है कि yes, when you are keeping a watch, when you are watching, when you are seeing these things, so just see that आपकी ये knowledge जो है, ये जो sound signal है, the sound also will be affected. So you try some restraint before you make a judgment कि ऐसा भी हो सकता है, isn't it? So this is also possible. Same thing, use of radar in fog. So use of radar in fog also you have seen. Meteorological factors may affect normal expected range of radars. So अभी आप जिन्होंने radar course किए हैं या use किया है radar, of course you see this, the radar range also gets affected. So if humidity decreases with height, super refraction is expected, resulting in considerable increase in the radar range. So this is again due to the humidity. Now if the humidity decreases with the height, then this thing takes place. On the other hand, if the humidity increases with the height, subrefraction takes place, may be expected with a consequent decrease in range. So ये fog के जो हैं effects वो भी हमें थोड़े से मान में रखने हैं, माइंड में रखने हैं when we are basically keeping a watch. यार fog तो formation हो गई, where all will get the fog, you are prepared. So at the same time these things are also possible, so we use caution. So the best thing is to use caution, be extra cautious that these things are possible, to be on the safer side. So whatever all methods available, we use that. So ये तो था आपका fog, various types of fog and various types of fog formation. ठीक है, I hope understood. Any doubts? तो इस पे क्वेश्चन भी सिंपल आते हैं. व्हाट आर द वेरियस टाइप्स ऑफ फॉग्स, एंड या स्ट्रेट वे भी लिख सकते हैं, डिस्क्राइब एडविक्शन फॉग, हाउ द एडविक्शन फॉग फॉर्म्स और विच ऑल एरियाज दिस फॉग इज नॉर्मली एनकाउंटर्ड. सो आई डोंट थिंक सो कि इसके लिए आपको ज़्यादा एफर्ट करना पड़ेगा. ऑफ कोर्स इट्स देयर इन द बुक ऑल्सो. So slightly I have deviated also certain extra things, that use of this radar, use of sound signals, how they get affected, and formation of the fog, how we can go about it. ठीक है, चलें नेक्स्ट टॉपिक पे चलें. एनी क्वेश्चंस फ्रॉम दिस?
No, no.
या चलो गुड. सो नेक्स्ट हमारा था कि व्हाट वी सी द जनरल सर्कुलेशन. Now general circulation of your winds. Now we have studied what is wind, how it forms, and हमने wind का काफ़ी स्ट्रक्चर भी पढ़ लिया है, फ्रॉम हाई प्रेशर टू लो प्रेशर. अब हम इसी के साथ देखते हैं आपकी जो जनरल सर्कुलेशन है. नाउ यू नो on this planet how this general circulation basically takes place. So it gives you a fair amount of idea where you are sailing and what type of winds you can expect and why these winds are basically working on these areas. Now general circulation of winds, if you see, if there were no seas, I mean there were no land, if there was only seas, फिर तो ये wind pattern जो है बिल्कुल steady होना था. All over the place there would have been the wind pattern which is like this, that near the equator, trade winds, westerlies. But अब यहाँ पे क्या है कि yes, on this planet we have huge land masses. अब land mass भी बीच में आ गया, seas भी हैं, and the wind pattern जो है थोड़ा सा disturb हो जाता है. Now if there was only seas, then of course you would have faced all the time same type of wind and wind direction. But due to these land masses, ये थोड़ा सा effect है. So let's see हमारी जो जनरल सर्कुलेशन है, how this general circulation takes place. So winds are comparatively uniform in longitudinal belts extending around the world, though some local exceptions are there. Otherwise basically you see near the equator what we call the doldrums, belt of variable mainly light winds, and then north of this doldrums or ITCZ, what we call, from 10 degree to 30 degree lies the belt of northeasterly trade winds. So basically if you see now, this is the ITCZ or doldrums, and from 10 to 30 degree you see this area is basically known as the trade wind zone. So these are the trade winds blow from here, and then again this yellow portion you see the variables 30 to 40 degree, and then 40 to 60-65 degree you have a strong westerly zone. So here the winds are in a very strong westerly direction, they blow. And of course above this up to 90 you have this polar easterlies where shipping is less. So this polar easterlies we have less information, but basically the direction here is the what we call the easterly, and this is the general circulation you see. Now wider belt of westerlies 40 to 63 and 63 to 65 the local areas of variable wind, and then of course further north you have northeasterly or the polar easterlies. So in the southern hemisphere similar sequence of latitude belts. So आपकी general circulation जो है it basically on the surface of earth it is like this, that in the middle near the equator you have 5 degrees up to 10 degrees you have what we call the doldrums, ITCZ intertropical convergence zone, and then up to 30 degree you have this trade wind zone. So here the direction of the wind is basically northeasterly. So हम देखेंगे how this thing takes place, how these trade winds form, इनकी formation कैसे होती है, and then further north you have westerlies, how these westerlies form. So ये भी, so this is the basic general circulation of the winds on the surface of earth. But individual places जहाँ पे आपके land masses आ गए वहाँ पे ये wind pattern जो है change हो जाता है, वो भी हम देखेंगे. वो भी है कि yes, when this wind pattern changes then we start calling them by different name like monsoons. Areas तो वही हैं, latitudes वही हैं, but now the wind direction has changed, wind pattern has changed due to the land masses. So आपकी winds के जो नाम है वो भी change हो जाते हैं. So let's see first of all what is this doldrums. तो अब ये चीज़ भी है, इसके ऊपर भी आपको रिटर्न में क्वेश्चन आ जाते हैं. राइट शॉर्ट नोट्स ऑन doldrums, southwesterly monsoon, northeasterly monsoons of Arabian Sea, isn't it? So ये छोटे छोटे टॉपिक्स जो हैं, now it's basically like a general knowledge, but very easily can be answered. Now what is this doldrum or IT season? It's a zone of light variable winds associated with rain and thunderstorms. So I don't know how many of you have passed through the equator. If you see this on the equator, many times you see a very good weather, and suddenly next while you pass, you see lot of rain, thunderstorms taking place. So that's why इसको doldrum कहते हैं, means uncertain weather, and it occupy a very narrow belt between equator to 12 degrees and varies with the longitude. ये जो belt है ये keeps on varying, ये नहीं कि fix है कि 0 to 10 or 12 degrees. Now this varies because of the sun's altitude, sun's declination. Sun starts moving from north to south. तो इसकी जो belts है, doldrums और ITCZ की belt also keeps on changing from the season to season. Sometimes they go slightly up, sometimes ये belt जो है 10 डिग्री से कम हो जाती है, sometimes it goes up to 15-20 degrees. So zone is dreaded by sailing vessels for risk of becalmed. If there is no wind, sailing vessel तो move नहीं कर सकती. तो इसके लिए इस areas में you find the sailing vessels सारा weather study करके तभी चलते हैं. So trade wind system of northern and the southern hemisphere. Now this area is the area where the trade wind system of both the hemispheres basically meet. अभी हमने diagram में भी देखा है. Now if you see here the wind is blowing in northeasterly and here the wind is blowing in southeasterly. So basically this is the meeting place of trade winds of both the hemispheres. Now because of prolonged heating over the equatorial oceans, some of the air finally ascends vertically. So ये भी हो जाता है. So same thing is ITCZ. This is the same name to doldrums, intertropical convergence zone. Same as doldrums, meeting place of trade winds of northern and southern hemisphere. That's why it's called convergence zone for the trade winds, tropical zones की जो winds हैं. So before that it used to be called intertropical front, but then the meteorologists realized no, the name was changed because of the vague and variable character of the accompanying weather. यार ये frontal, it's not a tropical front, it is basically like a tropical convergence zone of both the trade winds. Sometime northern boundary of zone will be marked by rain, storms, squalls, thunderstorms, and sometime it is a southern boundary. And mean position keeps shifting. अगर आप इसकी position देखिए तो अगर आपको you see in the month of January this is close to equator, then comes here, so it always remains in January it is between 0 to 10 degree. But if you see in July, now the sun is more on the northern hemisphere, so this ITCZ or doldrum area they shift like this. So this becomes your ITCZ, whole area shifts like this. Now this is due to the sun's altitude. So ये तो simple आ गया कि this is what basically doldrums or ITCZ. This is the meeting place. अब ये जो trade winds हैं, now how these trade winds form and why they are called trade winds. Now northern hemisphere, if you see, now equator all the time keeps getting warmed up. The sun is all the time shining on the equator. So this warm air around the equator rises and flows northward toward the pole. So ये भी है कि जैसे ही आपकी wind जो है, air चाहे sea surface हो चाहे land surface हो, when they start getting heated up, this air starts rising. So as the air moves away from the equator, the Carol's effect deflects it towards the right. ये भी हमने पढ़ा था. So as this air is getting deflected towards the right, and then it is rising also. And rising say means it will get cooled. So part of this air which gets cooled, so it starts descending back near 30 degrees. So up to 30 degrees it goes, and then it is become enough cool. It has no rising capacity, so it starts descending. It starts coming down. So जैसे ये वापस it starts coming down. That means now the winds are coming from north, blowing towards the equator, and then again Carol's effect जो है इसको वापस deflect करेगा. So this descending air blows from northeast to southwest back towards the equator. Why? Because अब ये north से आ रही थी, now it is going to get deflected towards right. तो इसकी direction almost northeast हो जाती है. So this is the air which is basically becoming cool after rising, and then it descends back. So a similar wind pattern occurs in the southern hemisphere. So these winds blow from southeast towards the northwest and descend near 30 degrees. So same way अगर आप देखिए तो ये नॉर्दर्न हेमिस्फीयर की जो ट्रेड एंड सदर्न की पैटर्न इससे अब certain parts of the wind. Now these prevailing winds known as the trade winds meet at ITCZ between 5 and 5 north and 5 south. Now remaining air जो है कि ये नहीं कि सारी है, हो सकता है certain air still keeps rising because we have seen the enough thermals are there, so it doesn't become enough cool to come down. So the air that does not descend at 30 degree north or south, it continues towards the poles and is again known as westerly. अब ये भी north को जा रही है, it will also get deflected towards the right because of the Carolis force. तो जैसे ये डिफ्लेक्ट होगी राइट को तो इसकी डायरेक्शन क्या बन जाएगी, ऑलमोस्ट से साउथ वेस्टर्ली, तो नॉर्थ से सो स्लोली इसकी डायरेक्शन भी वेस्टर्ली बननी शुरू हो जाती. सो द ट्रेड विंड्स आर सो नेम. वाई इनका नाम क्यों पड़ा कि ट्रेड विंड्स आर नेम्ड? बिकॉज द शिप्स हिस्टोरिकली टेकन एडवांटेज ऑफ देम टू एड देयर जर्नीज बिटवीन यूरोप एंड अमेरिका. अब सबको पता था कि ये ट्रेड विंड जो हैं दे आर ब्लोइंग. सो ओल्डन टाइम में दिस शिप्स दे जस्ट यूज टू सेल अलॉन्ग वन लैटिट्यूड कि ट्रॉपिक्स में आगे जहाँ पे आपकी ट्रेड विंड जैसे 30 और लेस देन 30 डिग्री लैटिट्यूड पे. सो दे नो द ट्रेड विंड्स जो नॉर्थ ईस्ट है कंटिन्यूसली दे विल कीप ऑन ब्लोइंग फ्रॉम नॉर्थ ईस्ट, सो दे विल टेक देम टू द वेस्ट. एंड सिमिलरली दैट्स वाई वहाँ उस वक्त तो ये स्टील शिप्स या स्टीम शिप्स वर नॉट देयर. सो शिप्स विच वर यूज्ड फॉर ट्रेडिंग वाज बेसिकली योर सेलिंग शिप्स जिनको स्ट्रॉन्ग विंड चाहिए थी. तो उस वक्त के बंदों की you can imagine the knowledge, meteorology की knowledge was very strong, so they knew कि कौन सी जगह कौन सी winds prevail कर रही हैं. So these winds which are basically rising from equator and then descending back at 30 degree and then again due to Carolis force becoming northeasterly, so they were named also trade winds because the trade was taking place with these winds. So trade winds are prominent all over the major seas areas both in summers and winters, as northeasterly in northern hemisphere and southeasterly in the southern hemisphere. Except उन्हीं latitudes पे if you come to Arabian Sea, Bay of Bengal, China Sea, यहाँ पे आपका जो wind regime है that is dominated by monsoons. Latitudes ऐसे हैं, होना तो northeasterly, basically winds तो northeasterly हैं, but इनकी direction जो है वो change हो जाती है. Why? Because of the land masses. There is a huge Asian continent is there. तो उसके करके अब इनकी जो इसलिए नाम भी इनका थोड़ा सा चेंज हो गया. मानसून्स दे ब्लो मोर और लेस कॉन्स्टेंटली थ्रू आउट द ईयर अबाउट लैटिट्यूड 30 टुवर्ड्स द इक्वेटर. ट्रेड विंड्स दे टेंड टू शिफ्ट नॉर्थवर्ड एंड साउथवर्ड फॉलोइंग द सन. द सन कीप्स ऑन मूविंग फ्रॉम नॉर्थ टू साउथ, इसीलिए ये ट्रेड विंड्स का भी जो शिफ्ट है दिस इज ऑल्सो कीप्स ऑन टेकिंग एज पर द सन. The movement is small in southern hemisphere, but in northern hemisphere it is 8 to 10 degrees of latitude in Atlantic and Pacific. Now you can imagine this whole pattern, whole this zone of trade winds also keep shifting 8 to 10 degrees in the northern hemisphere. And in Atlantic mean speed in Kia, the very good wind, 13 to 15 knots, not high speed winds and all that. That's why everyone prefers to sail in the tropical areas. Higher latitudes पे जाएंगे तब भी weather खराब है. Strong westerlies, gale force, lot of depressions, but in these latitudes up to 30 degree mostly trade winds. If you are going from east to west, favorable winds. Otherwise also they don't disturb the sea also because their force is only very less, 13 to 15 knots. Now summary formation of trade winds. Air is heated, risen in the ITCZ as a result of sun heating in low latitude, therefore low pressure in ITCZ. So this rising air cooled and sink at latitude of 30 degree, high pressure in the horse latitude. So above this what we call, they were known as the horse latitudes. And surface air from the horse latitude, that is from 30 degree north, it moves towards equator due to the pressure gradient. अब आपका equator पे due to this rising air there is a low pressure created. So that's why the winds from 30 degree they will definitely blow down towards due to the pressure gradient because there is a low pressure near the equator. तो ये सर्कुलेशन है. एज अ रिजल्ट ऑफ कैरोलिस फोर्स द विंड डिफ्लेक्टेड एंड रिजल्टेड टू नॉर्थ ईस्ट विंड इन द नॉर्दर्न हेमिस्फीयर एंड साउथ ईस्ट इन द सदर्न हेमिस्फीयर. सो दिस इज हाउ बेसिकली आपकी जो फॉर्मेशन ऑफ ट्रेड विंड टेक्स प्लेस. सो दिस विंड ब्लोज टुवर्ड्स इक्वेटर changing direction northeast to east, northeast to east due to the reducing effect of Coriolis force. And Arabian, Bay of Bengal, China Sea, monsoon suppress this trade wind. So यहाँ पे monsoons are strong. The monsoon is a basically Arabic word, means seasonal. Monsoon means seasonal winds. So seasonal winds अभी आपने देखा है, as we are waiting, southwest monsoon is going to come. How strong these winds blow. So they suppress this trade wind का जो system है उसको ये suppress कर देते. So in summer you see northeast trade wind suppresses by is pressed by southwest monsoon wind direction. In this region is southwest instead of northeast. तो है तो ये northeast trade, but in summer आपकी इन areas में Bay of Bengal, Arabian Sea, South China Sea, you find the wind direction instead of northeast it is becoming southwest because of the strange or this landmass heating. And in winter northeast monsoon reinforces the northeast trade wind giving gale force. अब as it is in winter अगर आप देखिए in areas में natural wind direction is also northeasterly trade winds, and आपकी जो monsoon formation है low pressure is getting created in winters in somewhere different place. So you find these winds blowing in the northeast direction towards the equator or down in the Arabian Sea, Bay of Bengal, and getting again what we call reinforcement with the northeast trades. And in China Sea, that's why you see northeast and southwest both the monsoons they create havoc. अब इनसे ऊपर अगर आप देखिए 30 डिग्री से ऊपर ट्रेड विंड्स के जोन से ऊपर यू हैव द वेरिएबल्स. वेरिएबल मींस द विंड इज वेरिएबल 30 to 40 over the areas covered by oceanic anticyclones between trade and westerlies. Further towards the pole there exists a light and variable winds which are known as variables. So 30 to 40 wind direction is always uncertain. Weather is fair with small amounts of cloud and rain. Westerlies, अब आप westerlies पे आगे, on the polar side of oceanic anticyclone lies zone where the wind direction become predominantly westerly. This is above 40 to 63. So unlike trades, these winds known as westerly far apart from the permanent. So they keep on changing because lot of depressions, lot of gale force winds are again experienced there. So continual passage of depressions from west to east cause these winds to vary. So वहाँ पे ये जो westerlies हैं above 40 they are not consistent as much your northeasterly trades are. Gales frequent in the westerly zone above 40 degree. That's why अगर आपने sailing की है higher latitudes में we are always scared of the bad weather, especially in winter. So this weather changes rapidly and fine weather is seldom prolonged. Now gales are so frequent in southern hemisphere that zone south to 40 degrees south is basically named as roaring 40s. So roaring 40s because if you see this area south of 40 degrees south, the wind actually makes a very roaring noise. Very strong wind south of 40 south if you go in the southern hemisphere, and in the winter especially these winds make really a very frightening sort of noise. That's why it's called roaring 40s. And in northern hemisphere fog is common, western parts of the ocean. So ये तो आपका wind pattern up to the westerlies. Polar easterlies not much concern because there is not much of the navigation. So seasonal winds and monsoons. अब ये भी है कि इस पे भी क्वेश्चन आ जाता है कि राइट monsoons तो हमारे कंट्री को ज़्यादा इफेक्ट करती है. So we should know. Anybody any idea how these monsoons form? क्या आइडिया आपको मानसून के बारे में? Okay, we talk about southwest monsoon only. I think almost going to touch Kerala maybe today or tomorrow. How these monsoons form? No idea? किसी को भी नहीं आइडिया? ऐसा तो नहीं हो सकता है. थोड़ा तो आइडिया होगा, मानसून तो आजकल स्कूल लेवल में पढ़ते हैं नहीं, हाउ दिस मानसून साउथ वेस्ट मानसून फॉर्म्स, कैसे फॉर्म होती है, ब्रीफ आइडिया, नॉट आई एम नॉट सेइंग एग्जैक्टली कैसे, बट आपके मन में क्या आता है?
When the heat causes variation between the ocean and land masses.
ठीक है, अब देखिए समर, अभी आपकी समर चल रही, क्या हो रहा है समर में, क्या हो रहा है, लैंड इज गेटिंग हीटेड अप, इजंट इट? वी ऑल फील द हीट। अब ये लैंड गर्म होगी तो आपने बेसिक पढ़ा है कि लैंड गर्म होगी तो एयर ऑल्सो एडजेसेंट टू दिस लैंड ऑल्सो स्टार्ट्स गेटिंग हीटेड अप, इजंट इट?
Yes.
अब जितना आपने देखा वो कहते नहीं यार अभी तो लैंड अच्छी गर्म नहीं हुई, बिकॉज जितना ज़्यादा 48-50 डिग्री टेम्परेचर जाएगा देन दिस लैंड गेट्स हीटेड अप, एंड इसका रिजल्ट क्या होता है? अभी हमने जैसे इक्वेटर पढ़ा है, सेम थिंग हेयर, कि स्पेशली इन दिस इंडिया, इफ़ यू सी नॉर्थ वेस्ट पार्ट ऑफ इंडिया जहाँ पे आपका डेजर्ट है, सो द लो प्रेशर, बेसिकली द सेंटर ऑफ लो प्रेशर गेट्स सिचुएटेड हियर इन नॉर्थ वेस्ट पार्ट ऑफ द इंडिया. Now you can imagine itni heat, the land has got so much heat and the air also has risen, and the air starts rising, तो naturally जो side की airs हैं from the high pressure they start blowing. अब आपने देख लिया यहाँ पे low pressure center हो गया because of the heating of the land mass. अब ये जो low pressure create हुआ है, what it will result? It will result the wind from the other areas from high pressure starts blowing toward this side. साउथ वेस्ट मानसून का सिंपल है कि आपकी जो सदर्न हेमिस्फीयर की जो ट्रेड विंड्स हैं, सदर्न हेमिस्फीयर की जो ट्रेड विंड्स हैं, उनकी डायरेक्शन क्या है? व्हाट इज द डायरेक्शन ऑफ दिस साउथ वेस्ट, आई मीन दिस ट्रेड विंड्स ऑफ सदर्न हेमिस्फीयर? दिस इज बेसिकली इन समर्स, इनकी डायरेक्शन साउथ ईस्टर्ली है, इजंट इट? ये जो ट्रेड विंड्स हैं नदर्न हेमिस्फीयर में तो नॉर्थ ईस्टर्ली ट्रेड है, अब नॉर्मल कंडीशन में इन सदर्न हेमिस्फीयर दिस साउथ ईस्ट ट्रेड इज ब्लोइंग, मीन्स दे आर कमिंग फ्रॉम साउथ ईस्ट. अब आपका यहाँ पे लो प्रेशर सेंटर हो गया, दिस इज आपका इंडिया, सो नॉर्थ वेस्ट ऑफ इंडिया, दिस इज द लो प्रेशर 994. नाउ इमेजिन दिस लो प्रेशर हैज़ बीन क्रिएटेड हियर, तो इसके लिए आपको यहाँ पे बहुत ज़्यादा स्टॉर्म आंधियाँ भी चलेंगी बिकॉज ऑफ द लो प्रेशर. तो यहाँ पे तो डस्ट है, सैंड है, वो सारी भी ब्लो होगी. एट द सेम टाइम यहाँ पे लो प्रेशर से ये जो विंड्स हैं सदर्न हेमिस्फीयर की विंड्स, दे स्टार्ट ब्लोइंग टुवर्ड्स दिस लो. सो इवन अफ्रीका कॉन्टिनेंट है, अफ्रीका में भी यही चीज़, वहाँ पे भी डेजर्ट है, तो वहाँ पे भी लो सेंटर क्रिएट हो जाता है, वहाँ पे भी लो प्रेशर है. तो ये सारी की सारी जो साउथ ईस्ट ट्रेड विंड्स हैं दे स्टार्ट ब्लोइंग टुवर्ड्स दिस लो. अब जैसे ये इक्वेटर क्रॉस करती है, बीच में इक्वेटर है, जैसे इक्वेटर क्रॉस करेगी नाउ इनकी जो डायरेक्शन है वो स्टार्ट्स चेंजिंग. इक्वेटर को जैसे इसने क्रॉस किया इट स्टार्ट्स बिकमिंग नदरली. अब कैरोलिस फोर्स जो है नदर्न हेमिस्फीयर में दे डिफ्लेक्ट द विंड टू राइट, इजंट इट? ये भी हमने पढ़ लिया. सो जैसे ये साउथ ईस्टर्ली इक्वेटर टच करती है फर्स्ट इट स्टार्ट्स बिकमिंग, बिकॉज इट इज हेडिंग टुवर्ड्स दिस लो प्रेशर टू फिल अप दिस लो प्रेशर, एंड सेम टाइम इसकी डायरेक्शन जो है ड्यू टू द कैरोलिस फोर्स इट विल गेट डिफ्लेक्टेड. सो ये इंस्टेड ऑफ कमिंग फ्रॉम साउथ ईस्ट इट विल चेंज डायरेक्शन टू साउथ. फर्स्ट ऑफ ऑल इट स्टार्ट्स, you see that it is coming from south and then इसकी डायरेक्शन साउथ वेस्टर्ली. सो द डायरेक्शन ऑफ दिस विंड चेंजेस फ्रॉम साउथ टू साउथ वेस्टर्ली, and that's why you see you get lot of rain here. This is the Indian coast. So first impact is here on the southern part of the India, Kerala side. And अब ये जो wind है this blows with a tremendous force. Why? Because pressure gradient is too much. यही पढ़ा हमने winds का, isn't it? अब आपका प्रेशर ग्रेडियंट है या 994 या 996 जो भी आपका लो प्रेशर सेंटर हुआ है, एंड हियर दिस इज अ हाई प्रेशर 1024. सी हाउ मच देयर इज द प्रेशर ग्रेडियंट 1020, 1024, 1020, 16. सो ये सारी विंड जो हैं दे क्रिएट हैवोक इन दिस अरेबियन सी. सो सेम वे अफ्रीका, हैवी रेन्स इन दिस ईस्ट कोस्ट ऑफ अफ्रीका, एंड सिमिलरली now why rain? Because these winds are coming from the ocean, it contain lot of water vapor, isn't it? So इनके अंदर तो they are fully laden. So जैसे ही यहाँ पे राइज हुई किया and touch the coast, heavy rain because moisture to full hai, relative humidity 100%. So yeah, you experience this heavy rain and slowly they keep moving. First they come to the southern part of India and then they start moving to north and even northeast. So northeast India also gets heavy rain due to these mountains. So ये रास्ते में इनके mountains आएंगे. So then again basically if you see in the Rajasthan side also, of course, sometimes the mountains are in the same direction, but if the mountain is just 90-degree opposite, so if this wind start rising, and we have seen as the wind rises, temperature come hoga, dew point, and further condensation. चलो ठीक है, टेक अ ब्रेक. ब्रेक के बाद देखते हैं ये साउथ वेस्ट मानसून क्या क्रिएट करती है नॉर्थ ईस्ट मानसून. बिकॉज अगर आपने एक बार समझ लिया देन इट इज़ वेरी इजी टू आंसर दिस क्वेश्चन, बिकॉज ये क्वेश्चन भी राइट शॉर्ट नोट्स के तौर पे आ जाता है. राइट शॉर्ट नोट्स ऑन मानसून regime इन इंडिया और साउथ वेस्ट मानसून और नॉर्थ ईस्ट मानसून. चलो ठीक है, ब्रेक ले लें एक चाय के लिए.
Yes, sir.
Yes, sir.
ओके,
Thank you, sir.
या 12:45.
Thank you, sir. Yes, sir.
Yes, sir.
ओके.